Today, we'll teach you another trick. With this flagrant reduction method, we use the larger number minus the smaller one, right? 42 minus 36. You see, the result is 6. Now, let's first check if 36 can be divided evenly by this result, 6. In other words, can the smaller number among these two be divided by the result? Divisible. You see, it works, right? 6 times 6 is 36, correct? 36 can be divided evenly by 6, so there's no need to keep subtracting. This 6 is the greatest common divisor of the numerator and denominator, so we can simplify the fraction directly. Now, let's see what we get. 42 divided by 6 equals 7, and 36 divided by 6 equals 6. So after simplifying, the result is 6/7. So have you learned it? Let's look at the second problem. It's the same method. For 40 over 48, I'll start by using subtract the smaller number from the larger one. 48 minus 40 equals 8. Now, do we need to keep subtracting further? Let's divide first and see if the smaller of the two numbers can be evenly divided by this result, 8. Look, 40 is a multiple of 8, right? So there's no need to keep subtracting. This 8 is the greatest common divisor of the numerator and denominator, so we can simplify the fraction directly. What do we get? Divide both the numerator and denominator by 8. 48 divided by 8 is 6. 40 divided by 8 is 5. Isn't that 5/6? And we're done. Now let's look at the third question using the same method. Subtract the smaller number from the larger one, and what do we get? 15. Is 105 a multiple of 15? Yes, it is, right? You see, 15 times 7 equals 105. So there's no need to keep subtracting. The greatest common divisor of the numerator and denominator is exactly this result, 15. Now, divide both by 15. What do you get? Isn't it 7/8? This problem is solved. Let's look at the last one. Subtract the smaller number from the larger one. 156 minus 143. What do you get? The result is 13. Now, can 143 be exactly divided by 13? Yes, it can, right? The result is 11, so it can be divided evenly. That means 13 is their greatest common divisor. There's no need to keep subtracting. Divide both the numerator and denominator by 13, and after simplifying, what do you get? The denominator is 12 and the numerator is 11, all done nice and easy. This method only works when the smaller number is an exact multiple of the result. What if it's not an exact multiple? Then we need to keep using the subtraction method to continue reducing. Let me give you an example to explain. For instance, what about a fraction like 15 over 25? What should we do? We subtract the smaller number from the larger one. 25 minus 15 equals what? It's 10. Now, I noticed that the smaller number, 15, can't be divided evenly by 10, right? So this doesn't fit the situation we mentioned earlier. What do? We have to keep subtracting, still using the larger number minus the smaller one. So which number do we subtract from which? 15 minus 10 gives us 5. At this point, 10 can be divided evenly by the result 5, so we do not need to subtract anymore. This 5 is their greatest common divisor. So here, if we divide both the numerator and the denominator by 5, what do we get? After simplifying, we get 3/5. Easy as that. Have you learned it?